Okay, on page 8 of the original plans, 1979, I want to talk to you guys about the shear plane that was created. Take note of the corner of the structure. Let's see if I can get you oriented. So that's the corner there, and take note of how it's, I call them shear planes, where if you were to try to demolition a building, where it would want to stand proud and not go down with the rest of the structure. So right here, as this structure was going down, depending on how you're attacking it, when the structure was being pulled down, the span from here to this column, there appears to be column, column, column. And then there's nothing here, and there's a setback. There's that deck to access this other upper roof deck, which I don't know. I didn't get that far into the plans yet, but take note of all these columns, all offering a straight plane of strength right here. So when this started pulling down, it ran against this, and it was able to unzip it, to rip it, tear it apart, tear it away from the structure, but not take down the rest of this, because these were had too much reinforcing backing, if you will, for it to pull it over. And that includes it looks like a nice consolidation of columns, not to be confused with I think these are your drain pipe, your 4-inch roof drains. RD, I think, is roof drain. I'm not sure. This is 1979 architectural plans. You'll probably have a legend to state what that is. This is his water pitch, I believe. You see these lines. This is what he wants the water to be loaded. So the water here will load on this roof, and in this section it will go here. I believe that's his intent, and the roof loading in this section. So he broke it up nicely where water would not be an issue. So one gets clogged, it can probably take the capacity of the other one, depending on the pitch. But you wouldn't let them get clogged. You'd keep these clear. All right, so he dissected the roof loading of the water loading pretty well there, and I believe he did it with the planter also. Interesting, the planters are original, and they've been addressed in his drawing. He does where applicable, or where you can, or something of that nature. Let me see if I can get you that planter right here. Section through 4x8 planters. So the planters are pretty large. 2'8" is the internal measurements, or the internal measurements, by 8 foot long, 8-inch walls on them. So there you go, and it's got soil in it. It can only hold, ultimately, it can only hold this much water, but it's displaced by the soil and the roots and the plants, and the roots and the plants that are inside this. Well, the plants aren't underground, so by the plants or whatever else they have in there. So it can only hold so much water before it overflows. So I don't, and it looks like it's part of this is so close to the edge of a column that it looks like it would transfer, or a wall transfer pretty directly. Well, not direct, but pretty directly. How's that? Meaning it's not in the midspan. It appears not to be in the midspan on that view. Now back to that shear plane, page 9. Yeah, 9. Did I just blow it over? There are a lot of load-bearing walls and columns inside their structures. Could someone have taken out one? I doubt it. I doubt they could have taken out one of those columns and gotten without. I doubt it. I don't think anyone in their right mind would do that. Plus, they had inspections of 68 units or something like that. So the engineer would have caught on there. What the hell? So no. I don't think anyone's that dumb to say, let me take out this huge-ass column out of my room. It's in the kitchens mostly, and they're in outside of walls. I don't think that's happening. So now we have a small apartment building. Maybe someone would be that dumb, but these things are of substantial size. So there's our shear plane. Let's look at it on this image. If we look at, there's that tower, this tower here. See the door right there, and it led to an upper deck, and then down. I'm sorry, it led to a little small deck, and then down some steps, platform, and it got you down to here roughly, I believe. So there's the shape of the roof. This create, looking at it literally, we can see that this creates a shear plane, and all of this pullout happened with this rebar, this wall. So when it tried to pull it down, it just transferred all the load resistance all the way down. There was nothing to buckle as it tried to pull it apart. As you can see here, as it ripped apart, here's a section of floor. As it ripped apart, it fractured. It bent this over, but it didn't strip it down. Here's another piece that didn't strip off. And here's another ledger piece that didn't strip off. You see the paint, the wall paintings there, and even here, this is all to help you put this thing back together in pictures and block. But back here is where it turns. Um, Remember in the video, it appears to start from the bottom column upwards, and that would still be somewhere about, in my mind, it's somewhere about, let's see, 1, 2, 3. This one here buckles down, so for some whatever reason, and it's transferred to the top of the structure, the top floors that pull down, and then that's when it starts. That I think the top floors collapse onto the lower floors, and then the lower floors collapse. I think the initiating is this column here right at this point with that video. Remember, they didn't give us the full video, so I reserve the right to let new data direct me to a new position, new thinking. All right, so we have this column pulling down. I have it pulling down. And we get the floor collapsing. Let's just do that. So where the heck is that video? Interesting, they monetized my videos, and I don't get any money for it. So turns out someone told me to do that to try to get it more out there, allow them to monetize it, even though you're not getting paid. So allow them to monetize it and get, possibly they'll put it out there more. But then I saw in the comments, if you guys see the people commenting too, I just came back to your channel, that no one's been sending me anything, any connections to your channel anymore. Google was blocking it. Now, I'm going to go step by step, frame by frame on this one, and somewhere right about this column here. So this right about here, and we're going to see the top roofing fall down, but we don't see these columns compress at this point. And so that's where I'm coming up with the failure, and this column being the initiating column. You see the transfer, the decks change direct. The columns only come this high over here, come a little higher to your left, and then they let's just watch it for a second. So you see that we're going to see that these start deforming first on this side, and at the same time we have deforming over here with the floors. So, and we have no deform, and then it appears right about, see, I'm going back and forth, and you can see a crouch, which crouching, and that's that column there, I believe, is our beginning failure. The movement's right there where I'm pointing with the mouse, and you'd have to go. You can see you can see right here the name of this video. You can go to it yourself. Then we get this deflection. Let's see if I can let it. Okay. So then I come back to the structure. Take a second. Let me pause it. So that would be, I believe it's this column here, or could be this column, but you see the floor, the levels, and then we get these floors collapsing down to here. There's a staircase I talked about, little platform. Then you come down to here, and the staircase got ripped off. Also went down with the rest of the building there. So this came down, fell here. It undermined it crippled and undermined. So it'll be roughly this one. So as this one came down, when it fell, this building leaned a little bit. You can see that our supports are huge here. From here to here is a large span. I don't know how it's loaded though, because we also have columns here to here, 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 and here. And so it had some resistance. Here's a plane of columns right here. 1, 2, 3, 4, 5, 6. That would have been a nice shear plane, and it held up for some time. And here the columns are, this one is a great span, but this might be an elevated shaft or solid wall that gave it some, a shear plane also that allow it to let that collapse. So let's collapse this one It's pulling. We saw it pulling on the top floors. It allowed the weakest, these floors being collapsing first, loaded each floor, overloading each floor, causing on the pancake. It went down first, and maybe it slid and hit the base column of this guy, or maybe it was already too far gone, breaking the, making it cantilever. So let's see if I can get you help you with this cantilever idea. All right, so well, I'll come back to the cantilever. But so you see the shear, the right at the last deck, the shear plane. That's that column that we're looking at. Columns we're looking at right here. This creates that plane, that strength. That when this building came down, this resisted. So if all these columns are good, you can enter the structure there. If all these columns are good, you can enter the structure there down from the foundation and clear out the building. We clearly have a video showing that it appears that your crouching down took place here, unless somehow you want the upper floors to fail, and then they overloaded this columns magically, and at the base it buckled. I don't think so. I think the original reaction is down here at the base. That's my thinking. So let's go to this one. So you can see again that this creates a nice shear plane, the solid wall all the way up. Look at that, solid wall all the way up, and that helps resist this collapse. They stop the progressive collapse. Somewhere back here we should start seeing columns. Maybe the column is here, and that's the outside wall. So here's our outside wall column going all the way down, and that would be here. Keep in mind that I don't know how much of this is stucco or how much of it is solid block wall, but that would also give it some shear panel resistance also. This is a lateral movement. There was also only, what, 1, 2, 3 rooms of depth. So out here it was 1, 2, 3, 2 rooms of depth that ripped off. 1, 2 rooms of depth here. Now the balconies were out here. That looks like it's buckled in right there. Buckled in. I don't know if it's buckled out. Maybe it's buckled out right here. From here to here, buckled outwards. Yeah, I'd go with buckled outwards. Yeah, from here to here. When this pulled off, it pulled the wall outwards. From here to here. Let's get to these images real quickly. There appear to be a nice set of 61 images. So here are our columns down there doing our shear plane. All right, let's, no, nothing personal. I don't care about that right this time. You can see how it pancaked and slid down. That one floor shifted over to the internal, so it tells you the inside columns broke on that tall building, on this tall section over here that was remaining. But these columns buckled, allowing the building to shift to your left, and as it couldn't just fall over. These became in tension. They probably tore from the pier, the connections where they fractured probably, and then as they fractured, the loads transferred down to these columns, and they just buckled these columns, and you get them the building after it shifted to the left just a little bit, then you get it just pancaking down, and that would be representative in here, where it shift inside towards here, because this was already down the ground, remember? And then this shifted to the inside a little bit, putting those columns in a great tension where they couldn't hold the building back. Those are already buckled inside, and then at some point, instead of still falling over, it just buckled all the columns, and you could probably see that the distance from here to here would tell you how much is at a plumb, how much the building was able to lean before it just pancaked down. And each one, including the top floor, at the impact, the sudden stop, buckled the columns internally. And we only see a couple of ones maybe punched through, like here, but otherwise the columns at this, when they collapsed, just buckled. Although there's some tall columns still in position over here against the wall that were torn off. Okay, so that's what's left. That's the column in there somewhere. I can go more deep dive into that, but that's not needed. Right here, you see where it pulled away. There's your shear plane, obviously, with a cold joint of some type, because it's a beautiful clean break. It only fell down to one parking garage, one floor. There's the planter slightly, a planter slightly off. The concrete's seems like it's pretty brittle. I mean, it's just destroyed itself. It'd be nice to get some core samples of this and check it. Nope, don't need to do that part. Okay, back up. I think they're rescuing one boy. They got lucky. It was back here. I don't know if it was. I don't think it's bedroom there. That's gonna be traumatizing for the kid. All right. Well, some fat firemen. FF. Remember the Italians, how they jumped in there and did their thing with the Morandi Bridge? With these people, you see them, they're just sort of like, whatever. There's that boy. Okay. So, they're just, whatever. Other countries, even, India and things like that, they would have had that all let the rubble hand moved out of there. They would have joined in and moved this stuff amazingly fast as a steel from the roof. Here, they're going to do all the slow and steady, slow and cautious. Don't worry about the fires killing people. Don't worry about, lack of oxygen. Let's just think this out for, days and days and days. And, until we're sure everyone's dead, and then we'll just we'll go after the dead bodies. That's my insensitive part. There's the turn, the rotation. You can see it also leaned it back. So, what I'd like to see is a magnet that they use for a scrap metal used to lift these panels up. Multiple magnets. Bring those out at these jobs, construction failures like this, and use the magnets to grab hold of that steel and lift them up in sections. It will stop drilling and everything, but a big magnet, the magnets to use right on the top deck. Just turn that magnet way up to grab through the concrete, to grab it through the magnetism to grab the rebar and lift up. I know the deck sections are huge. You can also lift up and cut sections and then move them away. Two cranes working in unison, and you can do that. But you already know pretty much the loads when you grab hold of it and you start picking it up. And they got load sensors on machines now anyway. Then there's their shear plane. So this up here, that was that one I said that looks like it's SHEARs, but it turns out it was just stuck on plywood, and it's been there since 2018. So yeah, you can look at the deflection on the roof, see if there's any deflection, and this is okay. I believe that's the column right here. See this column? So here's this here's the column, the load supporting column. What the hell is it supporting? What the hell is it supporting? Let's look at this real quickly. There's the column there. Well, that's that column. That's that wall 1, 2, and 3. And so it would be 1, 2, and close by. I think it was very close. 3, yeah, right here. And then turn, and there's that. All right, way before that. So back to this one. So 1, 2, and the third column. This is the wall here. What the hell is it supporting? That goes up to the ceiling. Did they pour each deck, and all of these are just your poured decks? Yeah, that's all they are. And then this just has a I'm trying to get you guys to see it. I'll let you see it in just now. So then that would really matter. There's a J hook. Okay. Okay, images. So that's what it looks like around a column. Trying to find something 1979. That's what it would look like around a column when you pour the concrete. Here's another version right near the base. Here is a retrofit, perhaps. Is that a retrofit? Here's another version. And then your concrete pad, when you pour it, it anchors to the column. And that's how you're transferring the loads down the column. Okay, this might be a nice one here to show you. Let's see if I can get a better one. Here's another version of it. Let's see if I can get you a better version. A little more, that's nice. Well, that's what it looks like if it didn't rip off. If it punched around, so it went around. See the support mechanism? It transferred the puncture to the outer surface of their anti-puncture, if you will, puncture shear. It just moved, as you can see this slab here, but this one it did it pretty close. All it did was move it out, make it in a great area, but it still failed. Okay, here is some. Here's a version of it with the studs. This might be the best one. Let's see. So this is how I believe they did each floor in the columns. They integrated it this way. And when it came down, just ripped itself away from the columns. And you saw that J-bar. That's what I was trying to find, the J-bar version of it. Okay, here's a floor that went, see, it punctures around these columns, and the floor fall down. But then this floor took it up. It didn't collapse. Yeah. Yeah, 1979. Can I find it with J-bars? 1979. Right there. This helps with flexural cracks and shear cracks coming across this way. But let's show you what I'm looking for. You see right here is, where'd you go? Where did you go? Little sneak. I gotta end this video because they get too long, right? Come on. Come over one again. Right there. This is part of our, right here, our puncture resistance. And it just, the bar just is still intact. It didn't straighten out. This bar is sort of like the FIU bridge thing now. We got the J bars that didn't straighten out. They didn't even deform. They look like they're in perfect condition. So that's an amazing feat in itself, which would indicate that you had some serious fractures of the concrete to pop it free from that connection. And this, like right here too. So it'd be nice for them to get some core samples of this stuff. Some core samples. All right, so that gets you up to date a little bit with why the building stopped at that location, why it stopped there, why it didn't keep going. And let's see if I can get you. So these columns transfer along with the walls down to the foundation. You can see obviously this is where we need to worry about right here, not over here. We saw the center go, then the far right. And why did it stop there? And so now you see that we have these columns are close proximity. I mean, they're really stitched up. And so when this, and the spans are great here. So they didn't have, as they were already pulling down, they already were disengaging with the structure. When I say disengaging, I want you to think of these right here stripping themselves out, the pull out of the concrete. It just pulled itself out of all these rebars, the full length. So it no longer had pull out. Oh, let me do this for you so you can understand. Rebar pull out test. There we go. Let's see if I can find the Hilti version of it. Hilti reinforced rebar bars pull test. Well, this one looks like I looked at it one time. So here is using a as simple as that. You put the rebar in there, grab hold of it, you pull it out. You want to see how the strength, and then you can go from there on how they're going to test, how you can rate your concrete, your reinforcement, how much more you're going to have to add, how close you're going to have them. This is after they've already installed some. The problem is that usually rebar can be closer than that, so your engagement is not true to feel, because these other holes can being closer can cause different zones to react differently now. Cones, they're cones basically. When you're pulling on something, you create an inverse cone inside there, pressure. And if you got another piece of rebar very close by, well, then it's going to hit that rebar, and that's going to allow it to, I think, fail sooner than not. Let's try this one. I want a faster test for you. One that's a little more clean and fast. All right, so he's firing it up. This is for it looks like something similar to a bridge railing, perhaps. He's got his tester on it. He's going to drop down his coupling. He's just going to use this regular SBS power team. There's his coupling there. My brain's frozen. The wedge. So he puts his wedge on it. That's it. And then this hydraulic ram is going to lift up, try to spread apart. The force, the pressure will be translated into the gauge. The gauge will then be translated into pull-out PSI. It's simple as that. This little 10,000 pound or PSI hydraulic pump will do that. You do the conversion along with the piston, though, that you're using to get your elevated numbers. And you'll see this pop down to 0 unless he has a gauge that will lock it in. Sometimes a secondary meter in there would be the one that would, when it popped to 0, it would show where it stopped. So usually hold it for a while. Once you get to it, you don't want to go fast with it, because you're exerting a shock force on it, and you don't want to elongate the steel. You just want to pull the steel out. Okay, he'll probably go up again. Yeah, and then it will. See, we only got a couple seconds left in the video. But now this is how you can check, for example, some existing steel in a structure. You want to know how it's doing with the rush jacking, etc. You can expose a piece of it, take some logistics to do that, and then pull at that bastard. And you would know what that structure is doing right there. You'd have a good idea, along with the compression test of the concrete. But this would be probably one of the best ones, because the steel is what's doing the holding of the structure together, the reinforcement. So this would be the most intrusive test, but the most conclusive test, I think, of what your structure would be all about. All right, so I've got a lot more to deep dive in. I just wanted to do the shear plane part of this. Goodbye.